Inveno Engineering LLC, we're global leaders in steam system engineering, recognized for our unmatched steam system expertise and dedication. Today, we would like to review steam line condensate removal, which is essential for a safe, reliable operation. All steam distribution lines must be engineered to ensure continuous and effective condensate removal under all operating conditions. Steam line condensate removal, steam trap stations are critical for safety and system performance. Regardless of insulation quality or thickness, heat loss will occur as latent energy is transferred from the steam to the surrounding environment. When latent energy is released, phase change from the vapor to a liquid occurs, resulting in a condensate formation within the steam line. Condensate will form on the interior of the steam line, and by gravity, drain to the bottom of the steam line. Velocity in the steam line will make the condensate flow in the direction of the steam flow. Condensate volume in the steam line will depend on several conditions: insulation, efficiency and condition, of course, steam pressure, length of pipe, and steam quality. The negative effects on the piping without proper condensate removal provisions, this unwanted condensate flow can lead to the following: erosion, water hammer, reduced thermal efficiency, poor steam quality. To ensure reliable operation and prevent condensate accumulation, properly designed drip legs and steam trap stations must be installed. Condensate is flowing with the steam at the bottom of the steam line. The condensate will not flow in a direct path at the bottom of the steam pipe, but in a swaying motion. Therefore, the steam line drip leg pocket must be large. The steam line drip pocket is the name of a branch line extending down from the main steam line and must be large enough to allow condensate to be drained from the steam line. Condensate removal from the steam line. Where do we have steam line drip leg pockets with steam trap stations? All low points. Remember one thing: condensate gets out of the steam line by gravity. So therefore, any low point in the steam line must have a drip pocket. Any change in the direction. Condensate wants to flow in a straight line. It does not want to turn right or left or up. So any change of direction, a steam drip leg pocket should be installed. Any valve that shuts off, either a control valve or even an isolation valve. As shown here in the picture, a drip leg pocket. So the valve is in a shutoff position. What's going to accumulate ahead of that valve? Condensate, and we want to remove it. Flow metering to ensure proper flow measurement. A steam line drip pocket should be ahead of the flow element. Now the question comes on a straight line: how far between steam trap stations should there be another steam line drip pocket? A rule of thumb, 700 feet. That's an estimated distance. We've done condensate removal pockets longer than that, just depending on the system design and conditions, ambient conditions. System needs to be reviewed for proper placement of steam line drip leg stations. And again, flow metering. Condensate removal from the steam line. Each drip leg must have sufficient volume accommodating the expected condensate load and minimizing the risk of carryover into the steam flow. Steam trap stations should be selected in size. Differential pressure between the steam main and the condensate return header is essential. Remember, inlet is P1 and outlet is P2. P1 always must be greater than P2, ensuring continuous drainage under all condensate load conditions. As shown here, steam flowing down the line shown here, and a change of direction up and a drip pocket is installed. Again, steam flowing down the steam line, change of direction, and again, another steam line drip pocket. Just typical locations where steam line drip leg pockets should be installed. Here, there's a 6-inch line with a 1-inch line inserted into the bottom. This is not a drip pocket. Condensate will flow down in a steam line, will not be flowing in a straight line, and the condensate will not flow into a small opening in the bottom of the steam line, and condensate will continue down the steam line, causing issues. Now, what should the drip pocket size be? 2-inch steam line, 2-inch pocket, 3-inch steam line, 3-inch pocket, 4-inch steam line, 4-inch pocket. Not until we get to 8-inch, we'll go to 1 pipe diameter reduced. We want to come down at least 12 inches, then to the steam trap station, and then 3 inches or more coming down to the blow-off valve. The steam line blow-off valve needs to be mounted on the side of the drip pocket below the steam trap connection. The blow-off valve is there for air removal at startup, which is critical, and condensate removal at startup, vacuum elimination at shutdown, condensate removal at shutdown. Steam lines must have air venting devices. Also, to remove air at startup, they can be manual or automatic. Here is a manual type air venting mechanism located at the top of the steam header. During shutdown, braking vacuum condensate to drain by gravity through the blow-off valve to set up a proper drainage. When the steam line's coming up on steam pressure, steam trap is not going to be able to remove condensate until P1 here is greater than P2. Therefore, we must have this valve here open to allow the condensate to drain out by gravity. Steam traps selection must be considered at operating pressure, condensate load, and available differential pressure to the return system. Float and thermostatic traps are preferred operational design steam traps for drip leg applications. Inverted buckets or thermostatic steam traps are other choices. Verification of condensate removal performance is critical to maintain long-term reliability and energy efficiency. During commissioning and regular operation, each steam trap and drip leg must be inspected for proper orientation and discharge characteristics and installation. Documentation. Performance trending enables proactive maintenance, energy loss quantification, verification of condensate recovery rates. Reporting should include percentage of steam trap operational, estimated steam loss if they're failed, and corrective actions. Incorporating these findings into the facility's reliability energy management program ensures sustained performance, minimizing downtime, and aligns with the corporate goals for energy optimization and energy reduction. Best practices. Proper condensate removal on steam lines. Select reliable steam traps for drip leg pockets. Use universal mount steam traps for this application. Air vents on all steam lines. Steam traps should have an internal strainer or external strainer, and use ball valves with Class 4 shutoff. The question is, what happens on Monday? To improve the steam system operation, change must occur. Inveno Engineering LLC, we are global leaders in steam system engineering, recognized for our unmatched steam system expertise and dedication. Unlike many self-proclaimed steam system engineering firms, we focus solely on delivering innovative engineering solutions, never products. Our commitment is to steam system engineering excellence, not salesmanship.